we have got a trig equation to solve. Now for this one, we've got two different trig functions in there. We've got sine and cos, and we've got a transformation of those functions. So we're thinking we're going to have to use one of our trig identities in order to make this equation only have one trig variable, and we're going to be using our cast diagram to find solutions in that interval. So the trig identity that we're going to use is tan x equals sine x over cos x. So if we divide both sides by cos of 3 theta plus 20, then we will be able to get a trig function just in terms, a trig equation, sorry, just in terms of tan. So we've got 4 root 3 sine 3 theta plus 20. We're going to divide all of that by tan of 3 theta plus 20. Sorry, not tan, cos. And we've got that's equal to 4 cos 3 theta plus 20. We're going to divide that by cos 3 theta plus 20. So dividing both sides by cos 3 theta plus 20. Okay? So on the left hand side we get 4 root 3 sine x over cos x. Here x is equal to 3 theta plus 20 is equal to tan x. So we get 4 root 3 tan 3 theta plus 20. That's equal to, here the cos 3 theta plus 20 cancel. So that's equal to 4. And then if we divide both sides by 4 root 3, we get tan 3 theta plus 20 is equal to 1 over root 3. Okay? We can now use our calculator to find tan inverse of 1 over root 3. So tan inverse 1 over root 3, that is equal to 30. So that is the value of tan inverse 1 over root 3. So we're going to use a cast diagram, and we're going to find our solutions between 0 and 180, but under this transformation. So we're going to go around the cast diagram a few times, because, for example, our first value of theta, we've got 3 theta plus 20, that's equal to 30. So 3 theta is equal to 10, and theta is equal to 10 over 3. You can see that once we undo the transformation, we're going to get a really small angle. So we're going to go round a few times, even though our interval is only between 0 and 180, because once we start subtracting 20 from our answers and dividing it by 3, we're going to get a smaller answer. Okay? So, drawing our cast diagram, we've got C, A, S, T. As a reminder, C stands for cos, A is all, S sine, T tan, and that is where those functions are positive. Now we're looking at when tan is equal to 30, so when tan inverse is 30. So we've got an angle of 30, and we're looking at these two quadrants. Okay, looking at the tan quadrant and the all quadrant. So we've got an angle of 30 with the horizontal. So here we've got 0, 90, 180, 270, 360. And we've got an angle with the horizontal in this quadrant of 30. So we're going to go round our cast diagram, starting at 0. We've already gone up to 30. That was our first solution. We're going to go round again, and we get our second value for theta, so 3 theta plus 20 is equal to 180 plus 30, which is 210. So 3 theta plus 220 is equal to 210. We've got that 3 theta is equal to 190 and theta is equal to 190 divided by 3 degrees. We're going to go round a second time because 190 divided by 3, that is still less than 180, so we need to go round again. Okay, so our second one, we've got 3 theta plus 20 is equal to, we've got 360, we've gone round 360 degrees plus an extra 30. So 360 plus 30, which is 390. So that must mean that 3 theta is equal to 370 degrees. And so theta is equal to 370 over 3 degrees. And I'm going to actually go round again. This is less than 180, but I'm going to go round again just to check if the next time I go round I get a value greater than 180. If I do, then I can stop. So we're going to go round again. All the way around to this one. Okay, so for this one, we've got 3 theta plus 20 is equal to, we've got 360 plus 90, which is 450, add 90 again, 540, we've got 540 plus 30, which is 570, so 3 theta is equal to 550, and theta is equal to 550 over 3. Now that is actually greater than 180, so we do not use that value of theta. So our values of theta and our solution is the first value of theta, which was the one we worked out here. That was with our angle of 30. When we undid the transformation, we got 10 over 3 degrees. Second value, that was this one, 190 over 3 degrees. And our third one was this one, 370 over 3 degrees. Question 4 is a logarithmic equation that we need to solve. We're going to be using our laws of logarithms here as well. So we're going to start by rearranging this equation so that we've got log of the same base of a function added together to use our addition law, okay, or our multiplication law, sorry. So we've got log base 11 of 2x subtract 1, add log base 11 x plus 4 is equal to 1. Now because the bases of these logs are the same, we can use the logarithmic law, log base a of x plus log base a of y equals log base a xy. So I'm going to apply that law and I get log base 11 of 2x minus 1 multiplied by x plus 4 is equal to 1. Now, if I then take the inverse of log 11 on both sides, I get 2x minus 1, x plus 4 is equal to 11. So now we have got a quadratic that we can solve, but we first just need to expand those two brackets. So expanding these brackets, we get 2x squared plus 8x, subtract x, subtract 4 is equal to 11. And 2x squared plus 7x subtract 15 is equal to 0. So I've just rearranged my quadratic here. Now this factorises to 2x minus 3, x plus 5 equals 0. So we've got two solutions here. Now, we've either got that this bracket is equal to 0 or the second one is. So we've got x is equal to 3 over 2 or negative 5. Okay? Now, if we actually look at our equation, in this logarithm, we've got 2x minus 1. If x was equal to 3 over 2, the function inside here would be positive. So that could be a solution. Similarly, if x is equal to 3 over 2 in this bracket, we've got a positive number inside the logarithm. So that could be a solution. So x equals to 3 over 2 is definitely a solution. However, if x is equal to negative 5, we would get 2 times negative 5, which is negative 10, subtract 1, which is negative 11. Similarly, we'd get negative 1 here. Now we know that we can't have a logarithm of a negative number. We can't take a log of a negative number. So, x must equal 3 over 2, and that is our only solution.